This one is good one.
Who is to ask me? What is I know ask me?
This is a claim.
What my best answer? It ain't. David Daniel, mute your.
Good morning to you all.
Good morning, sir.
Yeah, good
morning, sir.
Good
morning, sir.
Morning.
Morning, sir.
Good morning. I discovered that a number of your classmates, they don't join lectures. They don't know that I take record. I am saying this so that you can tell them I take record and I have the duration of each person's presence in my lecture. You should know at this stage, when you have a class of more than 1,000, one has to keep tab. So if anybody should fail this course, I will not be the one that will be at fault because I will generate for you that you were not in lecture or you were just in lecture, you opened and you left. That's number one. Number two, I discover as well that not everybody come to the lecture. The class will be more than 1,000 because the total number of you that you gain admission to engineering alone is outside the physics in your year one, you are about 800 plus, the whole of engineering. So if the direct entry is joining you, at least direct entry will be another 300 or 400. So on the account of that, the class will not be anything less than 1,100 on the stating it primitively. But the total number of people I've ever seen in your lecture is not up to 800. So whoever does not come to lecture is on his own because not only at this stage now, with the way things look, anyone who does not show up for lecture cannot just tell me that he knows what he's doing by himself. So there may be such people, they are already putting themselves in a very tight corner. So I need you to have this information And that's why I will not be releasing any lecture note to anybody. Go and pick up a textbook if you are not okay with what I'm doing, or you watch again on the YouTube what we have been doing. But for now, with the exception of the lecture 1 and week 1 and week 2, when I didn't make provision for people to be able to enter by themselves into the space because of the limitation of the YouTube of Zoom. Now that I have made that opportunity available, nobody can tell me he does not have opportunity of coming for the lecture. So anybody who doesn't come for lecture is on his own. Is on his own. Oh. So better pass that information. It's very crucial for class rep, because I will not listen to anybody who will come to me when lecture or exam results are out. I won't listen to you. And likewise, with regard to your lab will be starting in after the New Year celebration, after our celebration of the New Year. And I am repeating again, your matric numbers will come before your surname. I still see some people writing name before matric number. Matric numbers will come before your surname when you are writing all these things. I've said it before and I'm repeating it again. If you don't follow protocol that has been laid down, it just tells me that you are ready not to abide by rule and regulation. And on the account of that, I will not be liable, because if you don't follow it, it automatically will not permit you, because you know that in the world that we are now, if you do not do, if something is set on AI and you do not do the right thing, the AI will not just respond to you. So on the account of that, I don't want to entertain any question. No raising up of hand. I don't need any question from anybody. I'm just passing information. So don't
How can they ask questions where we
who is disturbing my class? I will remove you totally from my class. So once I see you making noise in my class, I will yank you off, and you will not be, I will just tell my Zoom setting that this fellow should not be allowed to come in throughout the remaining lifetime of this lecture. That means such a fellow will not be able to come in throughout the rest of the semester. You can't be disturbing my lecture. Okay, so we are about to start now. Some of my boys must be on the YouTube by now, because I think I have set up the YouTube for today's lecture. Last time I had only 300 on the YouTube, and I had about 290 something on the Zoom. So that tells me straight away that some people are not attending this lecture. But that will not worry me, because I have not missed my lecture since the university said we should resume lecture. So it's not a big deal to me that somebody decides not to come for lecture. It's a university system. I will use my attendance, because in University of Lagos, the rule says that if you do not meet up with 65% of attendance, you should not be allowed to exam all. And I'm going to make use of that to the letter. So because I'm a man under authority. Last lecture, we looked at, just a minute. Last lecture, we looked at, we started looking at the network theory. We were able to look at the nodal and mesh analysis, and we stopped at nodal analysis. I gave you a number of problems to solve, and then we were to enter into Supernode when I called it a day for last week. So we are continuing with Supernodes this morning. And as I always do, and let me tell you, when I ask questions and I ask people to respond, I know those who have been responding. The issue is that when I am grading and such a fellow, I will look out for them. It's not that I will give them extra mark, but the fact that they have been answering questions correctly in the exam or in the classroom shows that they are good and they are diligent with their work. So there is no way you will see such a fellow and you want to compare with somebody who never answered any question in my class. I think I need to make this very clear. So if I ask question and you know that you are part or you know it, you have to raise up your hand and be part of the people who will answer them. So we want to continue with nodal analysis this morning. When you are dealing with nodal analysis, there is a situation that normally come up or usually come up, which we call the fact that there are some nodes that you have a situation whereby there is a dependent source between or voltage source between two nodes, and it's trying to one way or the other make the node to be bogus for you to handle. So on the account of that, we normally handle that in a manner that will make the work easy for us. And how do we handle it? We normally handle it by making sure that we create what we call a supernode. A supernode, a number of times, we use it for the purpose of giving us opportunity to resolve the problem without recurring to some rules that guide the operation of the system. So that's what we want to look at this morning. I don't know if you can see my slide. Okay. So on the account, I believe you can see my slide.
Yes, sir.
Okay. Yes, sir. So on the account of that, if you look closely at this particular circuit, you will discover that there are three nodes, V1, V2, and V3. And between V2 and V3, there is a voltage source. So that voltage source creates a situation whereby we can come up with a supernode, because it may be difficult to resolve this. However, there are two ways or two cases of such supernodes that we normally encounter. The first one is that node, there may be no non-reference node at one end and reference node at the other end. What do I mean by reference node? Reference node is the one with the earthing sign, that you can see down here. But this V1 and V2, if you look at 10 volts by your left-hand side, the 10 volts, look at it closely. By your left-hand side, I believe you can see it, is between V1 and reference node. V1 and reference node. I hope we can see what I am seeing.
Yes, sir. Yes, sir. We can see it.
Yes, sir.
So this kind of case, this case one, is between V1 and reference node. And in that case, what you simply do is that you simply set the voltage at the non-reference node equal to the voltage of the voltage source. So the V1 will now be what? If I may ask you, Iwoma Opara Wilson. Opara Wilson. Is Iwoma your surname or Opara Wilson? Iwoma Opara Wilson. Which one, what will be the voltage of V1 from the case one that I have explained? Oyeyemi Malik, can you answer that question for me?
I think it's 10 volts, 10 voltage.
10 volts, then good of you. So case one means that V1 will be equal to V10, because the other side of the voltage source is reference node. So that's the case one. Thank you for that, Oyeyemi. So let's move to the next. I will remove this young lady from my Zoom this thing. I will remove her. So on the account of that, let's go to case two. Case two is going to deal with where we have that one that I put as supernode. But let's go to case two. The case two now is that if the voltage source is between two non-reference nodes, the current through the voltage source may not be known and an equation cannot be written for it. When you have two non-reference nodes, as we have here, as we have between V2 and V3. V2 and V3 now is a non-reference node. So you cannot easily get the current here if you don't set up a supernode here. And in setting up a supernode, we have this kind of arrangement that we have here. So you turn this place to supernode, the one with a dotted line, green line round about it. You have two nodes there and a voltage source. You make all of them together a supernode. And when you do that, you have created a possibility to just take it as a node. Though it is not a node, but you take it as a node. I need you to know that. That's why we call it supernode. It's beyond a node, but we take it as a node together. And what do we do with that? Look at what we do with it. So what we do now is that you make sure that every other thing is dotted. You can see it. Then you go around the loop in the clockwise direction. Remember, I've always told you, when you are doing loop analysis or mesh analysis, you must always go in the clockwise direction. Don't go anti-clockwise. That's my own convention. Some textbook may tell you to go anti-clockwise, but I want you to maintain only one approach. Go clockwise at all times that you are going around your loop. So in doing that, from your mesh analysis or from your KVL of moving around the loop of the circuit, you can see what we have here, minus V2. Do you agree with that? Moving from negative to positive, minus V2, from positive to, yes, from positive to negative, 5 volts, from positive to negative, again, V3. All of them together, because you are going around the loop, is equals to 0. So on the account of that, you have V2 minus V3 equals to 5. So that's how you resolve a supernode. So I state here that a supernode is nothing but a theoretical model in which we consider two non-reference nodes having an ideal voltage source present between them as a single node. We treat it as a single node. Two non-reference nodes with an ideal voltage between them, will lump them together and make them a single node. So I'm going to allow you to write the note. I'm going to give 2-3 minutes to that. So I will go back to case one. I just need to explain it. So please, I give you 2 minutes to quickly run through this. Put it in your lecture note now, because I will not give you any lecture note. I will not allow this Adebisi Olamide Solomon to ask me questions, because you have not followed my rule of registering your name. So you can drop your hand immediately. Alozie, can you ask your question? Let the Adebisi remove his hand right away.
Yes, sir. Good morning, sir.
Yeah.
Sir, please, could you go back down to that case 2? There's a question I want to ask there, please.
Let your colleagues finish writing this first.
Okay,
I'll go there in another 1 minute time. Don't forget your question. Still keep it in your mind. Badebo Marvelous.
Yes, good morning, sir.
Yeah, good morning.
Sir, for the supernode, Must it only be a 2 reference node or it can be more than 2? Must it only be 2 nodes or it can be more than 2?
You know, a voltage source can only be between 2 nodes. It can't be between 3 nodes. So even though I've never been asked this kind of questions since I've been taking this course for more than 10 years now. But at the same time, I am sure that I love the way you try to put your brain to work. But you should know that for every voltage source, whether ID or practical voltage source, you will have 2 terminals. One terminal to the negative, the other terminal to the positive. So definitely it is always between 2 nodes that I know. I don't believe you may have more than one voltage source. Like this particular one that is on your screen now. You can see we have 2 voltage sources.
Yes,
One
sir.
is between V1 and the reference node, and the other one is between V2 and V3. So you may have more than one voltage source in your circuit, and you will just resolve it the way we have explained it. But where you will have 3 nodes to make up a supernode, I would say it is not practically possible.
Okay, sir. Thank you,
Do I
sir.
answer your question, or have I answered your
Yes,
question?
sir. Yes, sir.
Okay.
Thank you, sir.
Because you always have 2 terminals. You don't have 3 terminals. So there is no possibility of having 3 nodes making a supernode. But thank you. It's a good academic exercise. Yes, Oloruntola, Mutiu. Alosi, I will go back to your question, but let Oloruntola ask his question. By now, everybody should have copied this. I want to move to the next slide. So Oloruntola, I'm
Please, I
listening to
don't
you.
understand. What is the difference between a reference node and a non-reference node?
Thank you. That's the kind of question I expect a fundamental student in your category to ask. You have not asked you have asked a very sincere question. It's not stupid at all. Reference node is a role. I told you that when you have a number of nodes, you must always make one your reference. I don't know if I can still see where I said that in the last lecture, except you didn't attend our last lecture. Look at it. I still have one here. I said node 0 is the reference node. And you said node 0 to V equals to 0. While nodes 2 and 1 are assigned V1 and V2. So for every, in fact, there is a place I told you, if I can see it, where I told you that if you have a number of, okay, it's on this slide. Read that number 1 by yourself, Oloruntola. When you are carrying out node analysis, read it by yourself. Step number 1.
Select a node as the reference node. Assign voltage V1, V2 to Vn-1 to the remaining n-1 nodes. The voltages are referenced to the reference node.
Okay, what do you understand by that one now? Okay, let me explain it to you so that we don't waste too much time. If you have n-1 nodes in a circuit, let's say you have a circuit that has 4 nodes. You will take one of the nodes as your reference node, and then you will have how many left now from these n-1 nodes? If you have 4 nodes and you have made one reference.
I said 3.
3. So you have V1, V2, V3. So your reference node, according to the following slide, after that, what do you make your reference node to be from this bullet point 1 after the circuit?
V0.
V0. V equals to 0. V equals to what?
0.
So the essence of your reference node is that you must always, in a circuit diagram, you must always set one of your nodes to 0. So that's why you have this 1. So the one here, the one with the earthing sign, is the one that you have taken as your reference node. Why you allow V1, V2, V3. So in this case now you have 4 nodes. But from fundamental information I have given to you, that you have read about nodal analysis, you turn one of them to reference node, and the other three, they are non-reference node. So that means your reference node is always 0 volts. It always has a value of 0 volts. And so everything will be referenced to it. Does it make sense to you now?
Okay, sir. Thank you, sir.
Okay, so you can drop your hand. So, Alozie, can I have your question now?
Yes, sir.
Go ahead.
No, sir, you will need to go down more. There's another diagram that you put.
Is
Yes,
it this?
this one. Yes, sir. That's first one that they said applying KCL at the supernode. If we go in a clockwise direction, moving from the negative terminal of V2 to the positive terminal, that would be a voltage rise, a positive voltage drop. It's supposed to be V2. Then it will now go through the 5V voltage source, and it's going from positive to negative. That would be in voltage drop. And then the same thing for V3. Isn't that supposed to be V2 minus 5 minus V3?
Okay, good of you. That's the principle that we always follow. But it's neither here nor there. If you follow this one that I put here now, you will see that it's either you will get negative for the answer that you will get, or positive. It will not change the value. It's only the direction that will be justified. Do you agree with that?
Yes, sir.
But at the same time, I totally agree with you. I will revert, because that's what I taught you
Yes,
from
sir.
our fundamentals, that when you are moving from negative to positive, let it carry this thing. That when you are leaving the source, the positive side to the negative side, you are trying to draw current from the source. So it should be negative. Is that not what you are saying now?
Yes, sir.
So, okay, if that's the way, but you will still, your answer will still be the same, whether you use this or the other way. But I will refer that back to that. So you can decide to use V2 minus 5 minus V3 equals to 0. You will still
Okay,
get
sir.
the same thing as this one that we are doing. And if you
All right,
look
sir.
at the way, if you look at the next line, which is V2 minus V3, you will see that it's almost what we have said. Do you agree with that?
Yes, sir.
Because by the time I move 5 back to the left-hand side, it will be minus 5. Alozie.
Yes, sir, you're correct.
So you are still correct either way. But in the fundamental, I will take note of that. I will not allow you to reflect like this again. Thank you for
All
that
right,
observation.
sir. You're welcome.
Ekunwe, what's your question?
Good morning, sir. Yeah, my question is about the number of nodes because I think it's confusing. The fact that we have a voltage source in between two nodes, does that create an extra node? If you look at the diagram to the bottom, left, that 10 volt voltage source is in between V1 and then the reference node. So um does that mean that, because if assuming that voltage source was not there, right, V1 would be the same node with the reference node? I don't know if that makes sense. So the fact that voltage source is there, are we saying that, like, is there, does it create that extra node? Because if when we are doing the analysis, for instance, that's 5 volt voltage source is in between V2 and V3, then you say, okay, then the node voltages will be V2 minus V3. The value for V2 minus V3 is 5 volts. Then when you do your nodal analysis, you get, like, I think 3 equations or so. So that's my question. I don't know if it's clear.
Okay. Now, what makes a place to a node is that there is always either an electric element or electrical element consuming energy or storing energy. What we make a node is that there is a consuming energy between the two of them or a storing energy element between the two of them. Anywhere you have resistor, capacitor, voltage source, current source between two junctions or 2 points, then that is a node. What makes a node is what you are correct. If that 10 volt had not been there, V1 and reference point will be at the same potential. But once an element is between the two of them, they can no longer be at the same potential. Do I answer your question?
Okay. Yes, sir. But
Okay.
I'd like to rephrase it a bit. Is there okay? So between V1 and the reference node,
Reference node.
is there a resistance? Does the voltage source actually have a resistance? Does it act as a load? Because thinking of it, if current were to flow through there, right? I don't know if like if there's no resistance, does it set up a sort of short circuit or like how?
That's what I said. Resistance is a load, energy consuming load, energy consuming element. But
There's
10
a passive
voltage,
element.
what you have here is a battery, which is energy storing element. And that's why I didn't use either resistance or capacitance or anything. And once you have energy consuming element between two nodes, that makes it nodes, authentic nodes. If you have a energy storing element between two nodes, it equally makes it a the two of them nodes. So whether there is an energy consuming or energy uh, storing element at a particular point between two nodes, you take them as nodes. But if there is no element between one point and the other, you cannot form a node there. You cannot form a node there once there is no element between them. But once you have an electrical element, it becomes a node. Okay. Are you okay now, Ekunwe?
Yes, sir. Thank you.
Okay. Now, Aregbesola, please make your question very fast so that we can go on. We still have a long way to go. Aregbesola, I'm waiting. Oh. We can't hear him. Uchechukwu.
Thank you, sir. Good morning, sir. I'm
Go
a bit
ahead.
confused with the current slide. You said applying KCL at the supernode, but it looks like it's KVL.
Oh, okay. It's KVL that we applied. That's why I said going around the loop. Going around the loop. Thank you for that observation. It's KVL, not KCL. We use KCL for nodes. We use KVL for mesh or for loop. Thank you for that observation. So it's applying KCL at the supernode. Though,
Sorry, sir.
though what we
Sorry,
have,
sir. Excuse me, sir.
what we have currently, I'm still going to the loop. I'm just KCL is what I mean by applying KCL is the second second circuit. I shouldn't have put it where it is. I should have just brought it to the second circuit, not for the first circuit. That's just the difference. The second circuit, the first circuit is okay the way it is, but you are still applying KCL at the supernode. If you look at it, you will see that the second circuit, you see I2 coming out, I4 going into the supernode, I3 coming out of the supernode. So that's where I'm supposed to put that. Sorry for that. It's for the purpose of explaining that I brought in that slide 1 for you to just be able to appreciate what I am driving at. I think when I prepared my slide initially, I didn't put that slide there. But it's to gather and to give you a better understanding of what I'll be doing with slide 2. That's why I brought in slide 1. So applying KCL should rather be with the second circuit. Thank you for that observation. So, Famuyide.
Hello, good morning, sir.
Morning.
Good morning, sir.
Yeah, thank you.
So my question is that when we move for the 10 volt voltage source, when current moves from negative to positive, we say there's a voltage increase. But for that 5 volt voltage source, when it moves from the positive to negative, there's a voltage drop. For when we're applying it with KVL, Kirchhoff's voltage law, that says that the sum of voltage in a closed loop is 0. That means that part is negative, right? The 5 volts is negative.
Somebody has asked the question you are asking now. And I said, I will reverse it, but it doesn't stop your answer from being correct. There's just the sign that will be different.
Okay,
That's
sir.
the question
Okay.
that Alozie asked me, that what I taught you people is that when you are moving from negative to positive, you are flowing I. That from positive to negative should be negative. I said yes, that we will still get the same answer, but the issue is that I will reverse myself and go back to what I have taught you before. But either way, you will still get the same answer, because if you look at the final analysis of the answer, if you move 5 volts back to the side of V2 and V3, you will discover that it will be V2 minus V3 minus 5 equals to 0. Am I correct?
Okay.
So
Yes,
what
sir.
you are still saying is correct. And I have already worked it out in my second step.
Okay.
But since what
Okay,
I
sir.
taught you is from generally, you should always use plus 5 V2 minus 5 volt minus V3. I would still prefer that you do it that way, and I will correct it in my own slide.
Okay, sir. Thank you, sir.
Okay, thank you. Finally, Ariori. Family, they drop your hand.
Okay, sir.
Ariori, what do you want to say?
Okay, sir. My question is that if you have a resistor connected in series with the voltage source, between the resistor and the voltage source, should we have a node in between them, or there's no need? Or
I don't understand, Ariori. Can you explain better?
in this case now, let's say beside the
Yes.
5 volt, there is also a resistor connected in series with it.
Okay,
Now,
I get what you are saying now.
between the resistor and the
I get
voltage
what
source,
you are saying. I already understand what you are saying. If you look at my explanation of what makes up a supernode, I will show it to you again in the last slide. I said, can you read it here? Ariori, read this for me.
if there is a DC voltage source between two reference nodes, two non-reference nodes, the current through the voltage source may not be known, and the equation cannot be written for it. Therefore, we create a supernode.
Yes. What makes us to create a supernode is when you have a voltage source between two nodes, two non-reference nodes, mind you. Does it make sense now? Once
Yes,
you
sir.
have a resistor there, you can resolve it.
Okay,
You know
sir.
that now.
Yes,
Either
sir.
resistor is in parallel to a voltage source or in series with a voltage source or parallel to a current source. You will be able to get your value. But when you have a voltage source between two nodes, there is no two way to it than to create a supernode. And there are problems like that everywhere that we want to try your ability to resolve. Thank you for that question. At least it opens the eyes of everybody to the fact that it is only when you have two nodes and voltage source between two nodes when there is no resistor or any other circuit element. So we move on from there. So here I say that when you applied your nodal analysis or KCL at node V1, you will apply it as well for you to get your nodal analysis. Apply KCL at the supernode, as I have explained before. If a supernode consists a resistor in parallel with the voltage source, the resistor exercises no influence. Can you see that? Ariori, I think the other part of the question now, do you see what I'm saying?
Yes, sir.
So you can copy this in your note as well. If a supernode contains a resistor in parallel with the voltage source, the resistor exercises no influence on the currents and voltages in the other part of the circuit, and therefore it may be ignored altogether. So a supernode does not have its voltage. Kirchhoff's current law and Coulomb voltage law are both applied to solve the supernode. I want to move on. So in solving this problem, this is how I resolve it. So you will form your KCL V1 minus V3 over 4 plus V1 minus V2 over 3. Can you see what I'm seeing? And you saw the voltage entering and leaving the nodes. Which is minus 3 minus 8. So you proceed further for the supernode V1 minus V2 over 3 plus V1 minus V3 over 4 equals to minus 3 plus V2 over 1 plus V3 over 5 minus 25. And you have a third equation here, V3 minus V2 equals to 22. So if you work these three equations, you will get your answers as it has been stated. I'm going to give you time to work this problem. Please go ahead and work this problem. Let me see your answer. I hope the guys on the Zoom, they are hearing us. Please, the guys
Yes,
on
sir.
Zoom.
Yes, sir, we are hearing you, sir.
Okay. Let the guys on YouTube also work this problem. and let me have your answer. You can send it to any of your colleagues who are on the Zoom platform, or you can send it to your class rep to paste it on the platform for us. Please work this problem first. I don't want to listen to any question, to attend to any question now. Work this problem first. I think I've done a lot of explanation. We still have a long way to go, and we have spent 1 hour. By now, I should be having answers to this. Who is ready to help us? Who is ready to help us? Alozie, have you worked it?
I'm in the process, sir. I'm almost done.
You are too slow now.
I'm coming, sir.
Fashioner, are you in this class at all? Fashioner. All these people who wrote their names without following my protocol, you have not attended this lecture. By the time I'll be harvesting my attendance, I'll just assign 0 to you. You can be sure of that. I will remove this one who is using Suavi, and he will not be able to come in again. Where is it? Let me remove this guy. Remove Suavi. My lecture is not where you just come and be a guy. Aigbu, I'm expecting answer from you, from Alozie. You guys have not been very, very active today. Aigbu, Daniel. All these people that don't have their full record, I'm going to be removing you any moment from now. Instruction is part of examination. Have you people not, are you not through with the solving of the problem? By now, I should have someone who can solve this problem for us.
So I'm done, but I got different answers.
Let's see
I'm
the way
done.
you work the whole.
All right, sir.
Let me drop my own slide so that you can call me. Okay, I've dropped my own slide.
Yes, sir. So can you
Okay.
see my work?
We can see, but it's not very uh, clear. Okay, it's getting brighter now.
Okay, sir.
Okay,
Okay, so this is using that mesh analysis method
we
where
can't hear your voice again. We can see
sorry.
your note, we can't hear your voice.
This is using that mesh analysis method. So across V1 and V3, there's a resistor of 4. And I is equal, using Ohm's law, I is equal to V over R. So that would be V1 minus V3 over 4. Then across V1 and V2, that's node 1 and node 2.
Anozie,
So,
establish first that you have a supernode.
yes, sorry.
Establish first that you have a supernode. Do you believe there is a supernode?
Yes, sir, which is this one here.
Or you didn't indicate it at all?
I would have been.
I
That would have
expect
been
you
when
to
I was
use
working.
either pencil or blue biro or black biro to show
This is
that you have a supernode, and from there you can now move on.
This is Supernode, yes, sir. Okay.
Okay, go on.
Okay, so
I just want
this
to
is
make sure that you do the right thing.
okay. So this across V1 and V2, we have a resistor of 3 ohms. So that will be V1 minus V2 over 3. Then which is equal to negative 3 minus 8, which is this current flowing into all these currents flowing into V1. And then
So your circuit, so that you can use it to explain to your colleagues.
that's what I'm saying, sir. Hold on.
Okay,
That,
it's okay now. It's okay now. You remove
yes, sir.
it
So
from the. We can
negative
see
3,
your circuit.
yes, sir, which is negative 3, which is this one. Then negative 8, which is this one, flowing into V1 is equal to the sum of the ones that are flowing out. This V1 over this V1 minus V3 over 4, then plus this V1 minus V2 over 3 is 3 ohms. That's assuming that V1 is both greater than V3 and V2. Alright, so that's our first equation. Our second equation is this V1 minus V2 over 3, which is this, plus V1 minus V3 over 4, which is this, is equal to minus 3 plus this V2 over 1, because this is V2 and this is our reference node. It will have a net voltage of 0 because our reference node is 0. Then we'll do plus V3 over 5, which is this. V3 is minus 0, which is our reference node, over 5, right? Then minus 25. Minus 25 because it is flowing in this direction instead of this direction. Right, that was what this arrow is indicating here. That's our second equation. Then the third equation, we now have V3 minus V2, which is this and this is equal to 22. We are assuming that V3 is greater than V2. because of the signs that were given in our battery source, because it will be flowing from the negative to a positive, it will be flowing from negative terminal to a positive terminal, and there will definitely be a voltage rise or a positive voltage drop. So definitely V3 will be greater than V2. So I simplified my expressions, and this is the equation 4 I got, minus 7V1, or rather, first what I did was, this equation 1, I multiplied everything by 12 because that's the um, lowest common multiple of 4 and 3. So multiplying through by 4 will get,
Alozie,
so
you didn't tag your equations with
I
numbers.
did,
It's
I
not
did.
good.
See, this is
Uh-huh.
equation 1. This
Okay,
is
where's your
equation 1.
equation 2? Yeah,
This is
okay, I can
equation
see
2.
equation 1.
This is equation 3.
Okay. But you should be
So
giving us statement before you go into any step that you want to solve. Equation 1 multiplied by this, you are just explaining it with mouth so that people
sorry, sir.
will follow. Even if they see your note without you being there, I can know what you are trying to do for me.
Okay, sorry, sir. So what I did was I simplified equation 1 because the lowest common multiple of equation 1, as you can see here, is 12. If you multiply 4 and 3, that will give you 12. And on this side is negative 11. Minus 3 minus 8 to give us negative 11. So what I did was I multiplied this by 12, which will give me 3 into V1 minus V3, plus then this one multiplied by 12, which will give me 4V1 minus V2. Then is equal to what? Minus negative 11 times 12 will give me minus 121, as you can see. So I simplified that to give me 7V1 minus 4V2. This is minus 3V3 is equal to 1 minus 121. That I call that equation 4, right? Then this is simplifying equation 2. Let me just use it. Now this is simplifying equation 2. This is V1 minus V2 over 3 plus V1 minus V3 over 4 minus V3 over 5 is equal to minus 3 plus V2 minus 25. So what I did was I now multiplied everything through by 60 because that's the lowest common multiple of 3, 4, and 5. And if you multiply them, they'll give you 60. So this part multiplied by 60, this part multiplied by 60 will give me 20V1 minus 20V2. Then for this part will give me 16V1. Sorry, this is supposed to be minus 16V3. This is supposed to be minus 16V1 minus 16V3. Then for this part is supposed to be minus 12V3. Because we multiply 60 by this, the 5 will cancel the 60 to give us minus 12. Is equal to what? 60 into, I simplified this to give us minus 28 plus V2, which is what you are seeing here. This is minus 28 plus V2. And then I added everything and brought V2 to this side to give me this equation. And then we have our final equation, which does this. So I used my calculator and I solved everything simultaneously. And then this is what I got. V1 is equal to this, V2 is equal to this, V3 is equal to this.
I
And
will
that's
need
those
you
were
to
the
look
answers I
at
got.
your. Thank you. You have followed the protocol and the steps, but I need you to look at it again and be sure that what you have done is correct. If it
Okay,
is
sir.
a physical class, I would have shown you my own calculation. But I
Okay,
will still
sir.
give you opportunity. It may be addition error that is causing it. You remember
Okay,
that you
sir.
made a little correction along the line when you were explaining to us. But you follow all the procedures. All the procedures are very, very well followed. Thank you for that. I
All right,
appreciate
sir.
you.
Thank you, sir.
Yeah. So we want to continue from there. Any question, please? Do we have any question regarding that before I allow Alozie to? Okay, so I will move on from there now. So I have an exercise here. This one is cheaper than the other one. In this case, this is not a super node. This is just a normal problem to be solved. Can you copy it? I said you should choose the reference point wisely and solve the current. Solve for the currents in the circuit below. So if you are given this kind of problem, you have to choose the reference node by yourself. I want to move on from here. I believe you have already copied it. So this place now, I can find the nodes voltages for this circuit. For the first one, and for the second one, I can find the voltage V. You can see V. V is across the 3 ohm resistor. And I then find I, which is the current flowing through 2 ohm resistors. And the two of them, they are between the two nodes. They will form a supernode with 3 volts, as you can see. And if you are to choose your reference, it will be the one under that will be your reference node. I hope this makes sense to us. So copy this as well. I want to move on. So we want to go to mesh analysis. What is mesh analysis? It's the general procedure that we use when we are to solve for currents, or we are moving around a circuit. We use mesh currents instead of element currents as circuit variables. And in most of those cases, we reduce the number of equations that must be solved simultaneously. Recall that a loop is a closed path with no node being passed more than once. For every loop, no node is passed through more than once. A mesh is a loop that does not contain any other loop within it. A mesh is a loop that does not contain any other loop within it. While the loop is a closed path with no node being traversed or passed through more than once. So on the account of that, mesh analysis provides another general procedure, just like nodal analysis for analyzing circuit. In this case, we use the mesh current. So a mesh is a loop that does not contain any other loop within it. You already know that. In mesh analysis, we assign mesh current and solve using KVL. We assign mesh currents and solve using KVL. And all terms in equation are in units of voltage. And remember that voltage drop in the direction of current flow, except for sources that are generating power. Take note of that. That's our convention here now. I said voltage drops in the direction of current flow. That is, in the direction of your mesh current. If your voltage is following the same direction, it is called voltage drop, except you are dealing with generating source. So look at this now. We have two meshes here. Mesh 1 is defined as I1. Mesh 2 is defined as I2. And you don't go through a node more than once if you are dealing with I1 or I2, as you can see. So on the account of this now, you can apply, we assign mesh current I1, I2, that's the first procedure. Then you will apply your KVL to each of the meshes. And you use your Ohm's law, which is V equals to IR in dealing with this kind of problem. And you solve, if you have 3 meshes or 3 loops, you will have 3 different simultaneous equations. If you have 2 loops or meshes, you will use 2 simultaneous equations, depending on the number of meshes that you have. So if you look at that, this particular problem that we have, moving through loop 1 or mesh 1, you can see the way we did it. When you are moving out, it is negative V1. When you are moving across the R1, because it is moving in the direction of the current, we have plus R1, I1, plus R3 into I1 minus I2. It will give you 0. And you do the same thing for mesh 2. By the time you do it, we have 2 simultaneous equations, which you can use your matrix to resolve using Cramer's rule and the rest. Or you can solve it by elimination method. So this is what we have. Let's assume we have this kind of thing. You can see the way this one is being transversed. And you can see the answer that is being obtained. So another case, applying mesh analysis to circuit containing current sources may appear complicated. When you have current source in your circuit, it may become complicated, but it is actually much easier than what we encountered in the previous slide. Consider the following 2 possible cases. Look at case 1. In this place, we have voltage source to your left hand side of the circuit and current source to your right of the right-hand side of the same circuit. Look at the resistors, the way they were connected. And then we said, when a current source exists only in one mesh, consider the circuit here, for example. We set I2 to be equal to minus 5 amps and write the mesh equation. So the mesh equation is written as you can see it. For mesh 1, you have minus 10 plus 4 I1 plus 6 into I1 minus I2 equals to 0. And since already set I2 to be equals to minus 5, so to get I1 becomes easy for you. I hope there is no need for questioning me here. Then we have case 2, where you have current source as you are having it here. Case 2 says when a current source exists between 2 meshes, the previous one exists to the right on only one side of the mesh, not being shared by the 2 meshes. But look at this one now. The current source is in the middle and it is being shared by the 2 meshes or 2 loops. At this point, what we can apply is what we call super mesh. Just like we have supernode. In the case of supernode, is when the voltage source is between 2 non-reference nodes. But when you come to mesh, super mesh now, it is when the current source is shared by two meshes or two loops. So when you have that kind of case, look at part B. Look at the circuit B. The way we try to look at it, we said you should exclude the current branch. The current source branch, you can excuse it for now by removing it. Then you have what we have on your right-hand side as the modified circuit diagram. I'm waiting for you to look at it closely. So your super mesh is because that current source is being shared by the two loops. And when you are to start your analysis, the first thing you do is that you expunge or you disconnect that link. And you will still have your I1 and I2. So I said that a super mesh is a technique used in electrical circuit analysis to solve complex circuits that have a current source being shared between two meshes or two loops. If there is a current source in the electric circuit, then the current source is treated as a super mesh when two meshes share a current source. The selection of super mesh paths must avoid current sources, but the current source is not known for its voltage because the current source is not known for its voltage value. I said you should treat the circuit as if the current source is not there. Then create an equation that relates the two meshes and their currents. And then a super mesh does not have its own current, but encompasses current from the individual meshes. I want you to copy this before I move to the next slide. You will understand it by the time I'm solving problem. So I want to move on. I want to move on now. Yes, I cannot answer a question from this guy because he did not follow my procedure of the lay-down rule of having your names on the slide, on the something. So forget about it. You cannot ask questions here. You are not permitted. As a matter of fact, you are not my student for the lecture because you didn't follow my laid-down rule. So you can lower your hand. You are not the kind of person I will answer your question. So I have already given you how to analyze Supermesh, identify the meshes, label the meshes and mesh current in a clockwise. I will always like clockwise direction. Remove the current source branch. Remove the current source branch that contains the current source that is common between the two loops. Then create the super mesh. Write the KVL equation for the super mesh. Find the mesh currents. Find the mesh currents. That's how you analyze super mesh. I'm not answering questions now. Let us see what we are doing first before you begin to ask questions. So if I give you this, because there is one amp that is being shared by two meshes, then there should surely be a super mesh here. And I ask you, solve for I1 and I2. Can you write this down? So the first thing you will do in this kind of situation is that you will have to remove or disconnect the one arm branch after some time. So look at what I have done here. You have 6 ohm, 4 ohms. You have voltage source, and the two meshes shared current source of 1 amp, and at the experiment you have the 5-volt voltage source. So we can write the equation for the branch that carries the current in this way. For loop 1, you have 21 minus I1, 6 I1 minus Vx. And for this reason, Vx is equal to 21 minus 6, 1, I1 rather. Then you now disconnect the mesh, the super mesh, the branch with 1 arm, and you have the next circuit to your left, to your right, which you can write each of the mesh equation as you have it. 21 minus 6 I1 minus 4 I2 plus 5, everything is equal to 0. And if you look at it, the two current, I1 and I2, will flow through the 1 amp branch. The 1 amp branch, the two currents will flow through it. So you have I1 minus I2 equal to 1 amp. So that means I1 is equal to 1 plus I2. So if you go on by that and we resolve this, you will have what we have here, 21 minus 6. Instead of I1 now, you substitute for I1 as 1 plus I2 minus 4 I2 plus 5 equals to 0. If you go further and solve this, because you already know that I1 is equal to 1 plus I2, you will have what we have, and then you will have 20, because 21 minus 6 plus 5 will give us 20. Then you have I2, which is 6 I2 plus 4 I2 will give you 10. So 20 minus 10 I2 is equal to 0. Then 20 is equal to 10 I2. So your I2 is 2 amps. Remember that I1 is 1 plus I2. So I1 is equal to 1 plus 2 amps. So I1 is 3 amps. So with that, we have I1 is as 3 amps and I2 as 2 amps. And then you can get your Vx now, because you already know your I1, which is 3 amps. That's 21 minus 6 times 3, which is 21 minus 18. So your Vx will be 3 volts. 3 volts. So, okay, I can now entertain question. Ariori, what's your question?
Okay, my question is that looking at the third diagram in at the right hand, the rightmost diagram, the I2 is moving from I'm sorry, sir. I've seen it, sir.
Okay, thank you. Thank you for your understanding. Then Bello. Bello,
Good
what's your
morning, sir.
question?
Good
Yeah,
morning, sir.
thank
My question is that third diagram, the third diagram, like the
you.
second equation and the third equation, like the equation is it maybe it is for the nodes, and again you said from your explanation that we should remove the node in order to get there. So because I was logged out and logged in back, so I don't understand like when
You
you said we should
understood
remove it.
you mean the third circuit diagram.
The sec yes,
You
the first
understood the first expression.
yes, the first expression is for the looping.
Yes. Then
So
the
like
second,
what I
you are
saw from
talking
the
about the
second one,
second line now.
yes,
The
like the
second
second
line,
I
the second one, I got it from my second, or you can pick the first circuit
okay,
diagram. You can see I1 is moving down when you are crossing, is passing through the 1 amp current. I2
yes sir,
is moving up.
yes sir,
So I1 minus I2 will give me 1 amp.
yes,
Do you agree with that?
yes sir,
It's not related with the third circuit, but I want to put them under one another. That's why I brought that one there.
okay sir, thank you sir.
It's from your second diagram or your original diagram. Okay. Lawal, what's your question?
Morning, sir.
Yeah, money.
Yeah, I have an observation from a particular material because I saw a question and I attempted it on mesh analysis, but the answer I have wasn't corresponding with the one in the book. And then I gave it to two scholars that I know in my department, and they solved the question too, and they get similar answer with mine, which is opposing the answer in the book. So I want you to see through this up.
They got.
I can show you the question. I'll just share my screen and show you.
That may be toward the end of the. Let me finish with my lecture. I would like you to remind me
Okay,
by
sir.
the time I'm through with my lecture.
All right, sir.
Okay. Yeah. But you understood this mesh on the super mesh and what we have done now.
Yes, sir.
Okay. And I must say this clearly. There are some questions that the answer may be wrong. Don't think you are the one that is wrong. Always. Once you follow the procedure, you follow the solution pattern that is expected, and you solve line by line. You may at times find some answers that are wrong from textbooks, even from highly intelligent authors. At least you have seen it here that we work some problems. You will call my attention that, this one, when I work it, I didn't get what you are getting. And I will discover that, there was a mistake here that I made. I was thinking I was still using 2 instead of using 5. So you may not totally be wrong from your observation. So let's look at this particular problem. I'm going to give you 5 minutes to solve this problem. My time is 9:31 now. By 9:36, I will stop all of you, and you will have to solve it for me. There is these are 3 meshes, and you have a particular source that is between 2 nodes. So you have a super node here, and you have a super mesh here. But one may not, okay. But you have to take, if you take your reference correctly, you may be able to overcome one of them. So you have to choose your reference. I didn't choose reference here for anybody. So take your reference based on your own judgment, and then go ahead and solve the problem. I want to see whether you can be judged, your judgment will be very fair and very matured and very academically sound. My friend on the YouTube, I expect you to always solve some of these problems, and I expect you to always communicate with me in your own way. You have spent 2 minutes, remaining 3 minutes. I told you that you cannot just write your name for me anyhow. I said you should write your matric number, surname and other names, and then your department. I can still see some people who do not obey this. I'll begin to remove you from the lecture platform. I'll begin to remove you from the lecture platform. Because instruction is part of examination. That's what we are taught. So I'm going to be removing some people right away, because if after spending 30 minutes, some people still be 1 hour, 30 minutes, some people want to keep doing things their own way, I'll begin to remove you guys. It's already time. If you have done it, let me see your hands up that you want to assist us to solve the problem. Ajani, all of you guys have not seen. None of you is raising up his hand or her hand. The ladies in this class have not been able to hear any of you answer my question. In my previous years, my ladies are always answering questions effectively. They're always effective in the class. Okay, maybe I should call one or two ladies now. Anjorin Olamide.
Sir.
No, I need a lady now. Olojo Nakanyisola. Can you I want to drop my own sharing. I want to see what you have done so far. Olojo Nakanyisola. I want to see what you have done so far. So Olojo in the class with us.
Sir, I'm
So
still
it's not
working on the question.
share what you have there with us. So I will drop my own sharing now. I need you to come up. Let me see what you have done. On your camera for me and come up online. Answer me.
Sir, my work is very scattered. It's not something I can show.
I say on your camera and let me see what you have done. You are not the one to tell me that. I'm waiting for you. If I give you another 30 seconds and don't do that, that means you were not part of this lecture at all. Ojo Tolulope, can I see your screen? Ojo Tolulope. Is Ojo Tolulope in the class?
Yes, he's in the class, sir. I'm a boy, I'm not a girl, sir.
Okay. Abiodun Grace. Is Abiodun Grace in the class with us?
Yes, I'm in the class, sir. I'm still working on it.
Yes. Share your note with me now. We want to see what you have done so far. Share your note. Let's see what you have done. You have the privilege to do that. I'm waiting for you. Olojola did not come to my class today at all. So Ojo Tolulope. Adigun Arafat. Can I see what you have done? Adigun Arafat. Share with us what you have done. I can't see you up. Adigwan Rafat, are you in the class with us? Salami Similoluwa. Salami Similoluwa. I'm jotting your names down. So I know those who are not in my class that just put on all sorts of. So when you see your result, there won't be any reason for anybody to. Zainab Adebayo, can you rewrite your name? Zainab Adebayo, I need you to answer question for me now. Turn it to Adebayo Zainab.
I'm in class, sir.
Show me your screen.
I'm still working on it, sir.
Let me see it, please. Let me see your screen.
I'm coming, sir. I'm having issues with my camera.
Snap it and send it to your class rep right away and let him forward it to me. Snap it on your WhatsApp, send it to your class rep. I know you are in PGD, and let the class rep send it to me right away. This 9:43.
Okay, sir.
9:43. By 9:44, if I don't see it, you were not in my class. Now, Anichuku Jessica. Anichuku Jessica. Are you in the class? Anichuku Jessica is not here. Adisa Blessing. Adisa Blessing. Adisa Blessing. Are you in the class?
Good morning, sir. I'm in the class.
That's Adisa Blessing, I guess. Is that Adisa Blessing?
Sir, Nichuku just come in the class.
Okay, go ahead and answer show me your screen.
Sir, I joined the class late. Can you show me? I'm still solving it, sir. Please, can I see the question?
You joined late. Since we started this lecture almost 2 hours ago. That's good of you. Where are you that they are making noise there? That means you are not even in this class. If they are making noise in where you are, that's surprising. That's very good. You should know that this is being recorded, so I can play this to anybody who will tell me that you were part of the lecture and that you participated when your result is coming out. Nobody will be able to say it was Oluseyi that was wicked to you. So that's the essence of my calling names now. And all of you, you have failed yourself. All the ladies in the class, none of you responded. That's very, very good. It is only the boys that have been responding since we started this lecture. And some of you that you wrote, you didn't write your name correctly, I've already deleted quite a number of you. And you can't come back to my lecture. Fashion of Peter. Fashion of Peter. Fashion of Peter.
Has the class ended?
Please, has anybody solved it?
I got an answer, sir.
What did you get, a beg?
My one was 4 amperes, while I2 and I3 1 ampere.
Sorry, can you say that again?
My I1 was 4. I got I1 as 4. I2 and I3 1.
Over.
Maybe. Please, can you share screen? Let me screenshot.
Just your screen, I beg.
The man has to authorize me to. I'm trying to do it now. It's not
Oh, there's no. You can share screen. You can try it.
I'm
And the man left already.
I think something happened, sure. But just whoever solved this, should just share their screen.
Sorry, there was loss of electricity here on campus. I just have to get myself together now.
okay, sir.
I don't know.
Okay.
Are my boys still on the YouTube? Let me check them. Are they still on the YouTube? Okay, they are still there. Sorry for the loss of transmission is due to the network challenge that we had here on campus. So we have this problem. Okay, somebody, Emmanuel, is Emmanuel your son name? I don't believe Emmanuel is your son name, so I will not attend to you. You have not followed my rule.
Yes, is my surname.
So I will not
Emmanuel
attend
is
to
my
you.
surname, sir.
Okay.
Emmanuel is my
Okay, go
surname,
on.
sir.
Okay,
Yes.
go on.
Okay, should I share my?
So, okay, you want to share your screen with us? Let me drop my own then. Yes. Go ahead. Share your screen with us. No, address, Job. Don't you know that this is an official thing?
Sorry,
Emmanuel,
sir.
please. I have said it. That's one of my ground rules. Dress as if you're in the classroom. You can see me
I'm
the way
sorry,
I'm
sir.
dressed. You can see the way I'm dressed. Let me move back a bit for you to see me. I'm totally kitted for you. It's an official document. It belongs to University of Lagos. So I cannot appear before you anyhow. In fact, I had to move to my classroom, to my office, I could have done it at home. I shouldn't be doing that. I should give you that respect. I know that you may not know, but please, I said it at the beginning. We are in an official environment. Even if you are staying in your house, it's still official because you are being recorded. Thank you for that understanding. Emmanuel, go ahead. By now, you should have put on. Yes, show us your screen, your notebook. We need your notebook. We are seeing your window, your house window, and your fan. We are seeing your house fan.
I don't understand how to put front camera.
And you are already, I'm seeing your note now. I don't saw your note, but it's turned upside down. You turn your note upside down.
How about now,
okay,
sir?
Very great, very great. Your area
Okay, so this
is very sunny, unlike where I am. Go on.
So this diagram that we are doing, we have this mesh
Our
one.
original diagram. You are not showing us the complete diagram. Okay, yes, yes, okay now. Okay now,
So we have
Emmanuel.
So we have
Move it
three
up a
meshes.
bit. Move it up a bit. Move your notebook up a bit.
Is this okay?
Yes, yes, correct.
Okay. So we have mesh one, mesh, and mesh three. We are taking each of the currents in clockwise direction. Okay, and then we have an independent current source between mesh one and mesh three. So that's where I'm start from. I'm going to start by creating a super mesh from mesh one and three. So can you see this diagram?
Yes, I can see it. Yes.
Okay, so this is mesh one and three
clear.
combined. Yes. So we are going to apply KVL around this super mesh. So starting with this 8 volts is entering the negative terminal. So we are going to put minus 8 according to your convention. Then we have 2 ohms. This is going in the direction of current flow. We are going to have plus 2 times the current that's flowing through this 2 ohms is, as you can see, this 2 ohms is in between mesh 1 and mesh 2. So we are doing I1 minus I2. So we have plus 2 into I1 minus I2. Then next we have this 4 ohm, which is between mesh 3 and mesh 2. I didn't draw, I forgot to draw mesh 2, but it's between mesh 3 and mesh 2. So we have plus 4 into I3 minus I2. Finally, we have this 2 ohm resistor here, which is the only current flowing through it is this I3. So that's 2 times I3. And by KVL, the total of everything is 0 around the loop. So simplifying all those things, we have 2I1 minus 6I2 plus 6I3 equals to 8. That's my equation 1. Finally, but before we move on to mesh 2, since that independent current source here is between mesh 1 and mesh 3, we say I1 minus I3 is equal to 3 amperes. So that's my equation 2. I1 minus I3 equals to 3. Finally, we've handled mesh 1 and 3 simultaneously. Now we are moving on to mesh 2. So taking KVL around mesh 2, we have, firstly, we have this 2 ohm resistor here, and the current flowing through it is I2 minus I1. So that's 2 into I2 minus I1, so 6. The only current flowing through 6 is I2. So we have plus 6 I2. Then this 4 ohm, we have I2 minus I3. Simplifying all these things, we have minus 2 I2 plus 12 I2 minus 4 I3 equals 0. That's my equation 3. So finally, from equation 2, we had I1 minus I3 equals to 3, right? So making I1 the subject of formula gives I1 equals I3 plus 3. Now we are going to substitute this I1 into equation 1 and equation 3. So substituting it into equation 1 gives 2, instead of I1, we are putting I3 plus 3. 2I3 plus 3 minus 6I2 plus 6I3 equals 3. Simplifying that will give us, I skipped some things there, but simplifying will give you 8I3 minus 6I2 equals to 2. That's my equation 4. Then substituting that I1 into equation 3 gives minus 2I3 plus 3 plus 12I2 minus 4I3 equals 0. So simplifying that as well gives us minus 6I3 plus 12I2 equals 6. So I use my calculator to solve equation 4 and 5 simultaneously, and it gave me I3 equals to I3 equals to 1 amperes and I2 equals to 1 ampere. That's what I have here. Then finally, from equation 2, we have I1 equals I3 plus 3. So I1 is 1 plus 3 is 4. So these are my final answers. I1 is 4 amperes, I2 is 1, and I3 is 1 ampere.
Thank you. Wonderful guy. I love what you have done. Thank you. Thank you. Thank you. Thank you. I will show you my own now. Are you seeing my screen now?
Yes, yes.
Okay. You are very correct with 2 answers, but there is one that you were not correct. So this is my own. You are correct. Sorry. You are very correct with all your answers. Exactly what I did is what my boy has done.
Yes, sir.
Thank you for that, Emmanuel Akpan. Good of you. Keep it up.
Thanks, sir.
So that's exactly as if he was looking at my note. That's exactly what he has done. So that means I can move on since somebody among us has been able to solve this same problem. Thank you for that. We'll soon be closing the lecture because I have another lecture. Can you take up this? You didn't answer any question here today. It was only Alozie that tried. All right. So can you copy this? All of you. This my friend from mechanical as well. You didn't answer any question here today. This guy from mechanical. You didn't participate at all today. Don't. So determine V3 by Supermesh from this equation. Can you copy this as well? This is like the one we just solved. Let me see if I have any other problem that I can give to you. Can you copy this as well? Another super mesh. Who is this one disturbing my class? What's his name? Faithful, you are disturbing my class. I believe you have drawn that. Can you draw this as well? Draw this as well. And draw this lastly. Draw this, get me IX. So that brings us to the end of lecture 2 for week 2 and 3. So we have been able to look at mesh analysis. We have been able to look at super mesh. We have been able to look at node analysis, we have been able to look at supernode analysis. Likewise, we have been able to look at our KCL and KVL. So the major network theorems have been dealt with. So by next week, we will move to the next stage of our study. Thank you. God bless
Thank
you.
you,
Do
sir.
have yeah.
Thank you, sir.
Yeah. I will let you know when to submit the assignment, the problem set 1. There are certain other work.
Sorry, sir. Sorry, sir.
There are certain other work that you will do online at the lab that we will give you the link later. There are some laboratory that is going to be done online that is not going to be physical. But your laboratory generally is going to be in January. So the other one that you have to use software, plan it towards that direction, that time. So do have a great time. Yes, what do you want?
Sir, good morning, sir. Sir, please, some of us on the LMS platform, they registered us for EEG211 instead of 211.
Okay, send me a mail. Let the class rep send me a mail so that I can forward it to our people in CITS.
Okay, sir.
Aibu, you can send
Yes,
a mail on your own. Since you are one of them, send a mail and put your matric number there. There are quite a number of you. You're on 311 instead of 211. That I should kindly ask for the rectification to be carried out.
Okay, sir.
Okay,
Thank
bye.
you, sir.
I have another lecture now. So send it to
Thank
my
you,
WhatsApp.
sir.
You don't need to come to class. You don't need to come physically. Just endorse the letter and snap it on PDF. Yeah, in PDF format. One person is enough. Let Aibu alone
Sir,
do
please,
it.
can we get your mail?
You didn't answer any of my questions, so I will not answer your own question as well. Because I asked ladies to answer questions, and you didn't answer. So it's only boys that have been answering my questions. So I'm obliged to listen to them. All the guys I asked questions today, none of them responded.
All guys are the same.
Okay, bye.